So we're going to use a couple different ways to solve our equations. If they're in the form that we have some quantity squared is equal to a number, we're going to use the square root property. And to do that, I'd get my quantity all by itself. So in this case, the x minus 3 squared. And then I can take the square root. When I take the square root and this squared will cancel out, leaving me just x minus 3. And then that would equal the square root of 64, which is 8. Here's a trick to this. This is a quadratic equation. Remember, the quadratic equations have these u's or an upside down u. So we could actually have two different answers. And so we don't know when that 8 is squared. Was it a positive 8 or was it a negative 8? Because 8 times 8 equals 64, but negative 8 times negative 8 also equals 64. So we are going to also have on the another option of x minus 3 equals negative 8. So we will have 2, and it's just that number that's changing. It changes nothing on that x minus 3. And then I'm just solving both of those. So x equals 11 and x equals negative 5. And again, we don't necessarily know if it's right at this point, if it's an upside down u or a regular u. But what's happening is on my graph, I'm really having a couple different points that would be crossing that x-axis, so we'd have two different solutions. On our second one, we would start by subtracting that 7 because we want to get that y plus 5 by itself. And then we get 21. I'm going to take the square root, which at this point means that I'm going to have two possibilities. Y plus 5 equals whatever the square root of 21, and y plus 5 would equal the opposite of whatever that is. And we're going to round that. When I put in the square root of 21, I get 4.58. We're going to round it to 4.6, and then be negative 4.6. So our answers, if we testing them out, will be a little bit off just because of the types of numbers that we have. When we're solving these, we're using that same minus 5 all the way across the board. So in this case, when we are putting those in, we're just going to go ahead and do that subtraction. So y equals negative 0.4. And then we'd have another solution at negative 9.6. Again, a lot of these will have two solutions because it's a quadratic equation. So we're going to either have 0, 1, or none. The next one, same type of a thing. It says during an experiment, a ball is dropped from a height of 205 feet. Since this is a height, that actually would be our initial height. So that's going to go into this equation here and can be used to approximate the number of seconds it takes for the ball to reach whatever height we want. We want to know when the ball reaches the ground. So when the ball reaches the ground, it's at height 0 plus 205. So what we want to do is get that squared piece by itself. So to do that, I'm going to do the minus 205 from both sides. And we want to get the t squared by itself just because I can. So I'm going to divide by the negative 16. And that 16 is really just a gravitational pull. We've seen that on a lot of different problems. I got 12.8125. I'm going to just go ahead and keep that number whole until I do the square root, and then I'll round it. At this point, I'm going to take the square root of that. And now I'm going to round that to 3.6. We could have 3.6 and negative 3.6, but because we're looking at a situation where we know that negative 3.6 doesn't make sense, we're not going to take that answer. So we'd say 3.6 seconds. Because when we're finding t, that's our time. So when we put it into a story problem, we don't necessarily look at the values that don't make sense in that problem. So that's our first method, and that works when it's in that particular form that we're able to do the square root. The other way is that we're going to be able to factor our equations. And when we factor, it's what we've been working with before. And so I'm going to look at something that multiplies to negative 24 and adds to a positive 5. So at this point, I know I have a y plus something and a y minus something, because if I have to multiply it to be a negative number, I need to have one of each sign. So if I start thinking of things for negative 24, it's going to be 1 and 24. And I know that the 1 is negative because when I add them together, I need that positive number to be bigger. Negative 2 and 12. 3 and 8 would be negative 3 and 8. And at that point, I can notice that one's going to work. So since it's a negative number, I'm going to put it in with the y's. This equals 0. And what the zero product property is telling us is that if one number equals 0, or one of those terms is equal to 0, then the whole thing has to equal 0. So if I can get y plus 8 to equal 0, it won't matter what the other term will equal, because when I multiply 0 by whatever that number is, it's going to equal 0. So what I do is I set y plus 8 equals to 0, and I solve. So y would equal negative 8. And then I would also solve the y minus 3 equals 0, because if that equals 0, the whole thing is still also equal to 0. And so y equals 3. Again, we have two possibilities. Looking at our next example, the first thing we need to do is move this 9x. So we're kind of going back to what we did the second day when we were doing our factoring, which is why we haven't done any of our formatives yet. I wanted you to have a little bit more practice. We're going to pull out that 3 because we want our x squared. We want that a term to really equal 1. And then we do that from every term. And now I'm going to factor the x squared minus 3x minus 4. This 3 is really still a part of it. I need it to multiply to negative 4. So if I'm going to multiply to a negative, that means I have an x plus and an x minus. I'm going to add to a negative 3. And so when I come up with my first pair, 1 and 4, that would have to be a negative 4 because I have more negatives. That would add up to be a negative 3. So I have that piece already done. Let's move these just to have room over here. That 3 I don't have to worry about. That 3 that's outside, because that it's a part of to show that I factored it correctly, that it would equal the equation that I have on top. But if one of these two terms is equal to 0, when I do 0 times 3, that would cancel that out. So x plus 1 equals 0. So x equals negative 1. X minus 4 equals 0. So x equals 4. And then I just want to make sure that you're understanding what we mean by when one of these terms is equal to 0. So this isn't what you would normally have to do, but if x equals negative 1, I'm going to have 3 and then negative 1 plus 1, and negative 1 minus 5, and I'll have 3 times 0 times negative 6. This whole thing is going to be 0 times negative 6 or equal to 0. So that's what we mean by if one of those terms is equal to 0, when I multiply everything else by, that's what's going to cancel things out. If a term is already factored for you, you just have to set each term equal to 0 and solve. Equals 0. And I get my two pieces. So that's the same thing, like 2, 3. 4 has some different terms, and same thing, we have another one in 3. We'll just look at it as 3. 4k plus 5 equals 0. So I'm just going to solve. So k is negative 1.25, and then k plus 1 equals 0. So sometimes there's just a little bit more solving involved. And then anytime it's in those factored forms, that's what you're working with. If they're not, this is what you're going to be ending up solving them. If they're not equal to 0, so all 4 of these, none of these equal to 0, I need to make them equal to 0 first. Most likely what's going to happen is you're going to say, this does not factor. And so they have to equal 0 in order for zero product property to work. It's that idea of putting it into the standard form. So I'm going to multiply to 24 and add to negative 11. If that part that you're adding to is bigger, that's just telling you how far apart your numbers are. So for some people that will help. Again, I know that if I'm going to multiply to a positive, they both are negative or both are positive. And if I look, that middle term is a negative, that means they both have to be negative. So a negative times a negative is going to be a positive, but a negative plus a negative is going to equal a negative still. So I could have negative 1 and negative 24, but that doesn't add up to negative 11. Negative 2 and negative 12, again, it doesn't add to negative 11. Negative 3 and negative 8, that also adds to 11. So if you don't need to come up with a list, you don't have to, but that list can be really helpful otherwise. This is now factored, but now I need to solve them. So x minus 3 equals 0. So x equals 3, and x minus 8 equals 0. X equals 8. So try a few more of these, check them with the answer keys.